In this lab, we will look at machine learning using Python programming language. In this lab, we will do exercises on machine learning. Let's load the most basic packages first. Import numpy has np, import pandas has pd. Step 1. We'll read the data from the file. The dataset contains information from the 1990 California census. Content: the data pertains to the houses found in a given California district and some summary stats about them based on the 1990 census data. The data aren't cleaned, so there are some pre-processing steps required. Let df equal pd, which is for pandas library, pd.read_csv of the file name with the extension csv. df.head, open and close bracket, that prints the first few lines. So we have longitude, latitude, housing median age, total rooms, total bedrooms, population, households, median income, median house value, ocean proximity. We can see that all the columns are numeric except the very last column, which seems to be a category column. Okay, step 2. We will look at the exploratory data analysis. Making ourselves comfortable and familiar with the data set is a fundamental step to help us comprehend the data and draw better conclusions and explanations from the results. Task 1. Plot one interactive box plot per each variable in the data set using Plotly. This will help us to better visualize anomalies and or outliers in the data distribution. So from plotly.subplots, we import make_subplots, and we'll use that to make the subplots. So let fig equal make_subplots of rows equal 10 and columns equal 1. So there are how many columns? Let's count. 2, 4, 6, 8, 9, 10. So there are 10 columns with the 10 column names, and we will create 10 rows and 1 column. So we'll use make_subplots from plotly.subplots library. So I import plotly.graph_objects has go. So this go, we will use it to create the to add the traces in the figure. And from plotly.offline, import iplot, and this iplot we will use to export the figure to HTML, the file name, to save the figure as HTML file. So to create interactive box plots of all the lab variables in the box plot, let fig equal make_subplots of rows equal 10, comma columns equal cols equal 1. So that creates 10 rows and 1 column. Let I equal 1, let j equal 1. For col in df.columns, in the column, the 2 dots. So this for call in df.columns, so we have df.columns, the 10 columns. So for loop is running through each of the columns. If I equal 1 for the start, I mod 11 not equal 0, colon. So the very first one is 1 mod 11, and that gives 1, so it is not equal to 0. Then fig dot add underscore trace bracket go dot box. So this plots the box plot, bracket x equal df call. So this column is printed horizontally, not vertically but horizontally, comma name equal call. So the name is given, here's the call. Call is the name of the column, comma row equal I. So first one will be row equal 1, comma column equal 1. Then I plus equal 1 adds 1 to I. So I becomes 2. Now we go through the loop for call the next call. If so I value is 2 mod 11 not equal to 0, then fig dot add underscore trace of go dot box of x equal the second column, comma name equal call, comma row equal I, row equal 2, call equal 1. Then I is incremented. So I becomes 3. Then for the next call in df.columns, if 3 mod 11 that is not equal to 0, then fig dot add underscore trace of go dot box of x equal the third column, comma name equal call, comma r row equal 3, comma call equal 1, and increment I. So when I is equal to 10, so call in df columns, that will be the 10th column. And if 10 mod 11 is 10 and that is not equal to 0, then fig dot add underscore trace of go dot box of x equal the very last column, the 10th column, comma name equal the 10th column name, comma row equal 10, comma call equal 1, and we increment I. That becomes 11. So 11 mod 11 not equals to 0. So we exit this loop. Yeah. Then fig dot update underscore layout of height equal 1300. So the height of each of the box plot will be 1300 pixels, comma width equal 1000, comma title underscore text equal interactive box plots to visualize anomalies and or outliers in the data distribution. Then I plot bracket fig, comma file name equal task1.html. So that saves the fig has file name task1.html. So when we run this, you have to run this. So we can see that the title is interactive box plots to visualize anomalies and or outliers in the data distribution. So for longitude we have this, and the second one is for latitude, there is no outlier. The third one is for housing median age, there is no outlier. And for total rooms we can see that there are many outliers, and same for total bedrooms and population, households, median income, A median income also has many outliers. Median house value also has outliers. Ocean proximity has one outlier. So the graphs show that we do have outliers in the data, especially total rooms, total bedrooms, population, households, and median income. Median house value also have some outlier. Ocean proximity is showing category island has an outlier. The box plot is submitted as task1.html file. Now let's look at this data. So we have for longitude, latitude, the maximum. Look at the maximum house median, housing median age. Yeah, so these have very high maximum. So this value, so we can see that we can't read the maximum, so we can increase this figure width. Say it is 1300. Let's run this. Yeah, so now we can read the maximum value, which is 52 for house median age, and upper, that's the upper fence, and the median is 29. That is the housing median age, and quartile 3 is 37, and quartile 1 is 18, and the lower quartile, the minimum, is 1. Let's look at one more variable, say total rooms. So total rooms, the minimum is 2, the quartile 1 is 1447.5, the median is 2127, the quartile 3 is 3148, upper fence is 5694, and the rest shows the outliers. In this data, the data set contains information from 1990 California census. The data pertains to the houses found in a given California district and some summary stats about them based on the 1990 census data. So let's look at population. For the population, the minimum is 3 population, and the lower fence is 3. Quartile 1 is 787, median is 1166, quartile 3 is 1725, and upper fence is 3132. The rest is outliers. For the proximity, the minimum is nearby, and the median is ocean, and the quartile 3 is inland, and upper fence is near ocean, and the island is an outlier. Means that there are very few people living on the island, very few houses on the island. So we find the number of houses located in the island. So df square bracket df dot ocean underscore proximity equal island, and that gives these 5 data rows. There are 5 houses located on the island.